Okay, welcome back, all my beautiful calculus students. We are going to move on to example number 10 using the natural log integration. So I have the integral of 6 over 5x natural log of x dx. This looks a little kind of crazy to me. It looks like I have a natural log in the denominator, and I have this x in the denominator, and I have these numbers I'm playing with. I'm really not quite sure how to even approach this problem. So I'm going to do like a guess and check and try and think it through a little bit. I'm trying to play devil's advocate here and pretend I'm you. How's that sound? So I know that the derivative of the natural log of x is 1 over x. But I don't have 1 over x sitting on my numerator. But I do have an x sitting here. So if I had a 1 over x on my numerator, and I had a natural log of x on my denominator, then I would have the derivative sitting on my numerator like I'm supposed to in order to manipulate this using natural log. Isn't this the same thing as if I let that x sit right next to that natural log? So they're kind of tricking me here. They're putting the derivative of my denominator on the numerator and simplifying it down at the same time. See that x getting attached right next to the natural log? That's what's happening here. And the 6/5 is just going to get factored out. So let's see what I'm talking about. Let's erase this and kind of brainstorm a little bit. You're going to have to do that once in a while because these questions can get tougher and tougher. So I'm going to take my 6/5 to the outside to get it out of there. I'm going to write the integral of 1 over natural log of x times 1 over x dx. Is that the same as everything that's up here? Because I want this 1 over x, maybe even to be sitting on the numerator, but over to the side works as well. All right, let me show you what I'm thinking in my head. I'm thinking let u equal the natural log of x. And then du would be 1 over x multiplied by dx. So that's kind of why I put it over to the side. I was kind of seeing this in my mind if I let u equal the natural log of x. So this here can become my u. All of this becomes my du, and I didn't need the 6 and the 5, so I factored them to the outside. So let's write this again. This is the integral of 1 over u du, which is 6 over 5, and I can integrate the integral from 1 over u, the integral of 1 over u du is the natural log of the absolute value of u plus c. My u was natural log of x, which is why this is so weird, but we have it once in a while. So natural log of the absolute value, my u has to go inside these absolute values, and my u itself was natural log of x. So this is very, very, very strange to actually have a natural log of a natural log. This is like a natural log is embedded inside another natural log function, and it happens. I'd like to say it never would, but it definitely will happen. Okay? Let's check this one. Let's take the derivative with respect to x of whatever I boxed right there. 6/5 natural log of the absolute value of the natural log of x plus c. When I take the derivative of 6/5 of a natural log, the 6/5 can just get copied. I'm ready for a fraction because to take the derivative of the natural log, whatever the natural log is being applied to goes to my denominator. So this natural log of x is what that natural log of x is being applied to. The natural log of x is in the denominator. What is the derivative of this natural log of x? It's 1 over x and then plus c. So this is 6/5, and 1 divided by x divided by the natural log of x is 1 over x natural log of x. And no plus c, plus 0. Am I crazy? Yeah, some days. Okay, this comes back into play. I end up with a 6 on the numerator. I end up with 5x times the natural log of x. And that matches my integrand perfectly, so this checks. That is the end of example 10. Example 11 is going to be a little funky as well. Okay, then I would like you to integrate 3x over the quantity of 2x plus 1 squared with respect to x. Okay. Now I have two thoughts that come to my mind. Number one is FOIL that denominator and break it apart. But if I FOIL that denominator, I'm going to erase this in just a second because it does turn out to be wrong. If I FOIL that denominator, I end up with 4x squared plus 4x plus 1. And this derivative, if I take it, becomes 8x plus 4. Now all I have is 3x. I'm not off by just a constant multiple. Okay? 8x plus 4, if I times it by 2 or divided it by 2 or did anything to it, I'm not going to make that 3x happen because that 4 is messing me up. So I'm not off by a constant multiple if I do that. It's kind of weird. And I know that many people are probably thinking, well, 3x over this, 3x over this, and 3x over this. Please don't think that. That is not proper. This is, if you had a polynomial that were upside down, and you had something like, oh, I'm just going to say 3x, I'll turn it upside down for you, 4x squared plus 4x plus 1 over 3x. Then you can split this into the same denominator 3 times, okay? But you can't split this into different denominators and think it means the same thing. This works. And we had a whole worksheet on polynomial over monomial. Okay, this works, that doesn't. All right, these are common denominators, so I could go ahead and put it right together again as one common denominator. Over there, if I broke it up, I wouldn't have common denominators. You can't do that. So we're kind of stuck here. So I'm going to do my other idea, is go to the side and let u equal 2x plus 1. I have to do something. And at least this would be my u here, and I would have a u squared on my denominator. That's okay. But what about this dx stuff? Let's see what we would do over here. U equals, so therefore du equals 2dx. But I don't have a 2dx, I have a 3x dx. Which means I'm not even off by a constant multiple, so I got to think of something else to do. And I can get my dx in terms of du, that's not the problem. I have my u being squared, that's not the problem. It's this x right here that's extra, and I need to figure out some way to get that x in terms of u's. If I can rewrite it in terms of u's, I can rewrite everything in terms of u's. So that's when you come over here and you say, well, if u is equal to 2x plus 1, then I could subtract 1 from both sides and say u minus 1 is 2x. I could divide both sides by 2, and I could get x is equal to u minus 1 over 2. And that's in terms of u. So, I mean, I really could do this thing. X is, what is it? U minus 1 over 2. And then dx, I would have to divide by 2, divide by 2. So my dx would be, I'm going to say 1/2 du would equal dx, so I'm going to put 1/2 du here. And now everything is in terms of u's. So I'm going to try this. Let's see what I can get from this and if it'll bring me anywhere. My denominator is going to say u squared. That's pretty clear. My numerator has a 3 on it, which I could bring to the outside if I felt like it. Yeah, let's bring that 3 to the outside, okay? This 3 is going to come out here. Now my x is u minus 1 over 2. Which, if I feel like it, I could just u minus 1 over 2, leave a 1 there. And now my dx is 1/2 du. I think this is going to work. I can see this happening now. So I have a 3 on the outside. I have 2 times 2 is 4 on my denominator. Let's bring that to the outside. I have a u minus 1 on the numerator and a u squared on the denominator. And look, all of a sudden I have a polynomial over a monomial, what we just got done talking about. So now I can split this. This is 3/4 times the integral of u over u squared minus 1 over u squared with respect to u. And you're going to rewrite it again, make it nice and neat. This is 3/4 times the integral. This is 1 over u, which is where my natural log is going to come into play right there, minus, and this is u to the negative 2, and I can use my power rule on that piece of the problem. So the 3/4 is going to get copied, open bracket. How do you integrate 1 over u? That's the natural log of the absolute value of u, minus u to the, I'm going to do our power rule, so we need to add 1 to negative 2, which gives me negative 1, and divide by my new exponent, which is a negative 1. Close my bracket and shove a plus c right there. Now, I know in your mind you're probably thinking, why are you bringing this u to the negative, u to the 2 that's on the denominator up into the numerator as a negative exponent, but you didn't do that for the 1 over u? If I did that for the 1 over u, wouldn't that be u to the negative 1? And if I tried the power rule with u to the negative 1, it would end up giving me u to the, what's negative 1 plus 1? That's 0, divided by 0. And division by 0 is undefined, which is why we never use the power rule when our exponent is a negative 1. And that's the purpose of having the natural log, whole concept of how do we integrate using the natural log function. And that comes into play when you have that negative 1 exponent. Okay, so this is going to give me, make it nice and neat here, 3/4 times the natural log of the absolute value of, now I'll leave it here for just a second, u, minus minus makes plus, u to the negative 1 is 1 over u, plus c, and one more step to put my u back into play. So 3/4 times the natural log of the absolute value of 2x plus 1 plus 1 over 2x plus 1 plus c. And that will be my final answer. Okay. And I only have 2 more examples for you. Let's see how I'm doing on time. We're looking at almost 12 minutes. I think I'm going to stop it there and I'll go back and do the other examples on another video. Okay? Talent out.